Hello. Today's video we continue discuss saga pattern, its second part, and we continue discuss this document. It's original scientific research about saga's pattern, and um, my video is about some ideas which I tried to find out in these documents and highlight for you. And these ideas are not well published. I mean, I cannot find any examples about these ideas because they are only contains in this document and maybe not so spread widely in the community. And I will try to find out useful for us and differences between how Saga's official documents and other resources, how they explain the saga patterns in comparison to this original document. Most information about how to use sagas in our with current technologies you can find in this article. It's a very great resource, and you can find details most information about the sagas. And I believe this document take into account information from this document, but with some differences. And I will try to highlight for you these differences. And I prepared a set of ideas. I marked them with a green marker. Yellow marker is the ideas and notes from previous video, from part 1. Today we will try to discuss deeply only ideas with a green marker. And firstly, I want to highlight, I want to highlight in current video two ideas. Its first ideas, it's about examples. This document contains several examples which can be implemented with the help of saga pattern. And we can briefly read about these examples. Firstly, for instance, I marked them. For instance, authors suggest to implement business logic of such ideas with help of saga, like produce monthly account statements at a bank. Another example, transactions to process claims at insurance company. And the last one, it is collect statistic over entire database. What is common for all of these examples? Actually, the idea under these examples that's when you're trying to do something with data inside database, you're trying to load a lot of objects from database and manipulate with them somehow. And during the load, actually, these objects in the memory, you put some read and write logs and read logs in database. You need to make one step back and try to remember that database has two type of logs. It's read-only logs and write logs. And when you try to manipulate with data, like select statements or insert or update statements, database setup acquire logs internally. And this all examples is about that's when you try to manipulate with objects, and amount of objects really huge, like millions records and more. Database will acquire a lot of logs in the database, and these logs will prevent another parallel transaction to update some data in database, because read logs will not allow to set up write logs, and that's why it's some conflict between logs, and that's why authors suggest to optimize such business process with sagas and split them into smaller steps of saga. And that's what common between all of these examples. And for me, it's very it's interesting to take into account this example. I will come to this example a little bit later. And let's briefly try to find another mentioned about such example. So we have mentions about this example, and let's try to think. It was a first idea of this video, and let's think it's one more example about all accounts. So it means during the saga you will affect some really huge amount of records in database. Please take it into account. Yes, one of the options of the saga, that saga can proceed all of its steps, otherwise it will be treated like unfinished saga, and somehow you need to finish it or roll back the saga. And another example with a lot of objects. Else you need to take an account that all experiments and ideas was checked with into this document was checked with centralized systems. I mean monolith system. But can be applied. But Saga can be applied to distributed database. Okay. Else this document introduce some semantics actually. According to sagas, how to implement them, how to name for commands, and so on. For instance, they suggest such term like a saga execution components. It's like some process which responsible for execution steps of saga, and each steps can be proceeded with transaction execution component. Let's to remember these two abbreviations. Also, this paper introduced some semantics like begin saga, semantics for the command of saga, like begin saga, end saga, abort saga, begin transaction, end transaction, abort transaction, and another command save point. You can read about save point into this document. Just to remind you that according to this document, we have two types of saga. One saga which is backward recovery, and another type of saga is forward recovery. Backward recovery saga is really explained in details into this document. This document is especially about sagas which are backward recovery, and I will not touch in this video this type of saga actually. I will only try to give more information about what does it mean forward recovery sagas. And we will take in account only these examples to understand how saga should work. You can read about this here, but another. Also, what does it mean saga from perspective of current scientific research? Just a file. It's a saga model. It contains in a file, and this file expresses the sequence of steps which treat like a separate local transactions, and these steps absolutely independent from each other. It's absolutely separate steps, and I mean they separate in terms of locks. I mean, if first step acquires some read locks, they are released after finish the current step, and next step of saga does not have acquire logs from previous step. You need to understand this idea to understand how saga should work. Another example with a lot of objects in example how saga can affect help to work with a lot of set of objects from database. And another example, compute interest payment for bank accounts. It's like a batch operation. And Saga is just a file which can be executed from perspective of this document. Okay, what else? This is very interesting. So Saga can be performed. Steps of Saga can be performed in can be proceed in parallel regime. So each step can be run in parallel. And this paper use fork and join semantics from Unix systems to run parallel steps of Saga. And from this paragraph, we need to take an account that's start and fork and join a child process is responsibility of Saga execution component, which was mentioned above. I mean, you need to start some main process which runs Saga model, begin and start a Saga commands and responsible for this command, and this process can fork child process, but take in account that's exactly main process Saga execution component responsible to run to fork new child process. It's responsible to wait until this child process finished. And another main idea that Saga execution components also responsible to move Saga from previous step to the next step. I mean, Saga execution component, it's central component, it belongs to some main process, and it's responsible to invoke steps from one transition Saga from one steps to another steps, like we can see into this diagram from the right side. And this is very important idea because it show us the difference between how Saga expressed in the current paper and how Saga explained in this article. Because in original paper, author suggests that invocation of the next steps is the responsibility of some main process. And but in this idea, in this article, we see the difference because in this case, for instance, choreography-based Saga, it's the same with orchestration-based Saga. That's if you post some orders and create an order, send event about this, and after that, Saga, which started from the left side, does not responsible for the next steps. It's wait some invocation from outside component, and because it's already not a responsibility of this component which started the Saga. It's wait some external event from external process or system and so on, and to invoke the next step of Saga actually. And this is the difference between this implementation and how it expressed into this document. It's second part of this, second idea of this video, which I want to highlight for you. Another example with check Saga. Check another example that Saga main contains steps which trying to read some information from database. In other words, steps which trying to acquire read-only logs. And I want to return back a little bit to example with this example, when we try to affect a lot of objects from database, and Saga and I want to try highlight the idea. Actually, according to this example, I believe that Saga can contain steps which are not require write logs, and these logs, I mean, Saga contains steps which and during these steps business logics require only read-only logs, like select statement only, and so on. That's why it's a very interesting idea. But because previously, according to this example, you see that if you create an order, you should acquire write log in local database to write something in database. And from another side, you have another component which also trying to acquire write logs, because you need to reserve some credit on in your component in your local database, and both of these steps require some write logs. But it is different. But this paper, I believe, suggests also to have some steps inside the Saga which requires only write logs. I mean, steps which contains, in other words, these steps may contain only select statement, for example, without any update, insert, and delete statements. And this is another differences between this article and original document. And I will try to discuss this example in next video. I will prepare some example in the term of semantics of current document, and we can try to in details understand how Saga can work with the steps which contains only read-only operations. And probably that's all from this video, and try to understand and try to rethink these two ideas about which was about which this video. And thanks for watching. Let's wait next video. Bye.